last class we are discussing the exothermic and endothermic reaction, enthalpy changes and their reaction profile diagram. So this we have already studied that for an exothermic reaction, heat is lost from the reactants. So the value of delta H is negative. And for endothermic reaction, heat is gained by the reactants. So the value of delta H is positive in this case. So whenever you are drawing the reaction pathway diagrams, activation energy arrow should start at the level of reactants and it should end at the highest point on the energy sum. Okay. When drawing the arrow for delta H, make sure that the arrow point downwards for an exothermic reaction and upwards for an endothermic reaction. Because in endothermic reaction, heat is gained. So you have to show the arrow upwards, and in the exothermic reaction, heat is released. So the arrow should point down. Okay?
Okay.
You want to write it? Or we have covered?
Yeah.
Some standard conditions which you need to know for studying the standard enthalpy of combustion, standard enthalpy of formation, standard enthalpy of neutralization. So standard means there are certain conditions which you need to take in the reaction mixture. Pressure should be 101 kilopascals, okay, or 1.01 into 10 raised to the power 5 pascal. Temperature should be 298 Kelvin or 25 degrees Celsius, and each substance which is involved in the reaction, it should be in its normal physical state, solid, liquid or gas, at 101 kilopascal and 298 Kelvin is the temperature. Write down the standard conditions. That means at these conditions we are measuring our enthalpy. Symbol which is used to indicate that the enthalpy change which you are doing, it is the standard under standard conditions. Okay, small 0 and the dash in. Basically, you can write it as 0 only, like delta H naught. We can call it naught also. So this reaction is what methane is burning, the combustion of methane to produce carbon dioxide and water. So the symbol is delta H means it is enthalpy change, but delta H naught means enthalpy change under the standard condition. Okay, so this reaction states that when 1 mole of methane it reacts with 2 moles of oxygen gas, it forms 1 mole of carbon dioxide and 2 moles of water. This is how we read a balanced chemical equation. So its standard enthalpy change should be minus 890.3 kilojoules per mole. That means the standard enthalpy change which is measured at 101 kilopascal and 298 Kelvin temperature. Okay.
Okay.
There are many enthalpy changes, but we are focused on only important ones: enthalpy change of formation, enthalpy change of combustion, and enthalpy change of neutralization. Okay, so these are some enthalpy changes which happens according to the type of chemical reaction that takes place. So first is your standard enthalpy change of reaction. It is represented as this symbol is for change, H is for enthalpy, this is for standard, and this R is for reaction. So all the terms have their particular meaning. So it is the enthalpy change when amounts of reactants shown in the stoichiometric equation, it reacts to give products under standard conditions. Okay, that means it should be reactant and products should be in their standard state. Its symbol is this, and this enthalpy change can be exothermic, it can be endothermic. Okay. For example, the equation is given here: hydrogen is reacting with oxygen to form water. So its enthalpy change, that is your standard enthalpy change of reaction, is minus 286 kilojoules per mole. So this shows us what? This shows that this is the enthalpy change when 1 mole of water is formed from hydrogen and oxygen, which are themselves in the standard state. Hydrogen exists as H2 gas, oxygen also exists as O2. Okay. However, if we write the equation as this, if I have multiplied the equation number 1 by 2, then equation becomes this. So if I am multiplying it with 2, you can see that my enthalpy is also multiplying by, okay, that becomes minus 572 kilojoules per mole. So here minus sign means that energy is released. So it is an exothermic reaction. This reaction is your exothermic reaction. So how can you identify this reaction? So you just have to see that your reactants and products, they should be in their standard conditions. They should be under standard conditions. Okay, so that is your standard enthalpy change of reaction. Is it clear?
Yes.
Write it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done.
Next enthalpy change of formation. Standard enthalpy change of formation. So its symbol is delta H. This is small f for formation, and this is the symbol for standard. So it is the enthalpy change when 1 mole of compound is formed from its elements under standard condition. You can see here 1 mole of iron oxide is formed, 1 mole of carbon disulfide is formed. So in this, only 1 mole of product should be formed from its elements under the standard condition. Okay. For example, reactants in products must be in their standard state. Iron exists as solid, oxygen exists as gas, carbon in the most stable form is graphite, and sulfur exists as a solid state. Enthalpy change for formation, it can be exothermic or endothermic. For example, this is your exothermic and this is your endothermic. We write the formula of the compound in square brackets. For example, enthalpy change of formation, and this is the product. Okay, to help us to do calculations when we are showing the enthalpy change. Now, the state symbol for carbon is shown as graphite because there are several forms of carbon. It is diamond, fullerene, but most stable form is graphite. So we write the most stable form in there. Okay, when writing the equation for the standard enthalpy change for formation. By definition, standard enthalpy change for formation of any element in its standard state is 0. So this line is very important. This will help you in solving the numericals. That the standard enthalpy change of formation of any element, say for example sodium, magnesium, if it is in its standard state, then the standard enthalpy change of formation is 0. Is it clear?
Yes.
Copy. The important thing you have to remember in enthalpy change of formation is that here only 1 mole of product is formed. You have to make only 1 mole of product. You have to do the changes in reactants only to make it 1 mole of product. 1 mole of compound is formed from its elements under standard condition.
I'm done.
Next enthalpy change of combustion. So this small c denotes combustion. Okay. Here it is enthalpy change when 1 mole of the substance is burnt in excess oxygen under the standard conditions. So what is standard enthalpy change of combustion? Enthalpy change when 1 mole of substance, this is 1 mole, this is also 1 mole. 1 mole of substance is burnt under the standard condition. They should be in their standard state. It is represented as delta Hc naught. They are always exothermic because in combustion, always energy is released. Delta H is always negative. Okay, so you can see here enthalpy change of combustion for sulfur is minus 296.8, for methane is minus 893 kilojoules per mole. Okay, so this equation, this is your equation number 1. It can be considered as either enthalpy change of combustion or the enthalpy change of formation of sulfur dioxide, because here also 1 mole of sulfur dioxide is formed from its elements under the standard conditions. Can equation number 2 be also called as the standard enthalpy change of formation? Tell me. Equation 2. Equation 2 is not called the standard enthalpy change of formation because here 2 products are formed. Okay, and in the enthalpy change of formation, only 1 product with 1 mole is formed. So equation number 1 is enthalpy change of combustion of sulfur and the enthalpy change of formation of SO2. Is it clear?
Can you repeat what you just said again because the screen got stuck?
Yeah. By I'm saying that I have written two equation number 1 and equation number 2. Okay. So I'm asking that equation number 1 is called the enthalpy change of combustion of sulfur. It is also called the enthalpy change of formation of sulfur dioxide because 1 mole of sulfur dioxide is formed from its elements under the standard condition. So I'm asking, is equation number 2 is also the standard enthalpy change of formation of carbon dioxide or not?
It's not.
Yes, because here two products are forming, which is not the correct definition for enthalpy change of formation. In enthalpy change of formation, only one product is formed. So I'm just telling you that one reaction can be, if you write one reaction, it may be more than one enthalpy change. It may be standard enthalpy change of combustion also, and it may be standard enthalpy change of formation also.